We were viewing the case of repeaters and hubs and the case of LAN switches, and now we need to study the case of the network devices called routers. A router, in fact, is an Internet port device that operates at the layer 3 of the OSI reference model, and the router could interconnect different segments of LAN and WAN technologies. The routers will forward the packets, the PDUs, called datagrams or packets, using the concept of destination address-based routing. Then within each router, there is a table called routing table. The routing table shows the route to follow to reach each destination. Then when the router receives a frame, decapsulates the frame that has inside a datagram or packet of level of layer 3, and examine the header of the datagram or packet, for instance, the header of the IP datagram, the Internet Protocol datagram, and based in the destination, the IP address destination, the router will choose the best route to follow in order to forward the datagram or the packet over the appropriate port and to the appropriate next hop. When the router don't know which is the destination, which is the route in order to send the packet based in the destination address of the datagram is dropped. Then this behavior differs from the behavior of the LAN switches. In the case of the LAN switches, when frame were destinated to an unknown address, the LAN switches flood the network. In the case of the routers, when the router receives a datagram destinated to an unknown destination address, for instance, because there is no route that matches that destination address, then the datagram or packet, IP packet, is dropped. This is an important behavior because this kind of behavior avoid the occurrence of the loops that we saw in the case of the LAN switches. Then if we use routing instead of LAN switching in a network like this, no loop will happen. And then we don't need to implement any kind of spanning tree protocol like in the case of the LAN switching devices. Another difference is that the end systems, in order to exchange the IP datagrams or IP packets from one end to other end, we only need to know the IP address. that is different from the MAC address of the end systems. The IP address is a number that is conceived in such a way that permit the optimization of the routing tables within each router. The use of this kind of mechanism, that is the routing tables and the destination address-based routing, enable, for instance, the implementation of additional functions. For instance, the load balancing. The load balancing, for instance, permits that if datagram, if a flow of packets need to travel from this end system to this end system, the load balancing could send some datagrams across this path and other datagrams or packets across this other path. In the case of if we analyze the case of, for instance, a network like this, the use of a destination address-based routing permit that this router decide based in the destination address which is the better destination. For instance, in order to reach this end system, the datagrams transmitted by this end system will follow typically, for instance, this path. But in order to reach an end system, for instance, in this site, this router will decide to reach this site across this path. And finally, for instance, in order to reach a destination address in this site from this server, this router decide to send those packets across this other path. Then all the links could be used in a routing in a routed network. But in fact, if we used LAN switching technology instead of routing technology, remember that the spanning tree block one of those interfaces, for instance, block this interface, and then a tree is formed using these segments and remaining maintaining a blocked or unused this segment. And in that case, for instance, the messages that need to travel from this end system to another end system in this site will travel across this path and not across this one that is a better path to reach the destination. This is one of the reasons, an important reason that permit or that need to be used that explain why we could need to use routing instead of LAN switching in several scenarios. Finally, when we use routing functions, there are special devices that could be used in order to provide protection, for instance, perimeter protection in a network. And in that case, we could use a router for this purpose. And in typical cases like this, the router is in fact is called a firewall. That is a router that perform complex functionalities of traffic filtering. Then, in order to have a big picture, we could compare the different internetworking functionalities like repeating, bridging, switching, and routing. Then in this table, we could see the differences between repeating hubs, bridging and switches, and routing or routers. In the case of the store and forward, remember that the hub doesn't perform a store and forward. That's why the router is not able to adapt different bit rates, and the hub or repeater doesn't perform any kind of filtering and can't avoid collisions and can't separate any kind of domains, for instance, like the broadcast domains. And finally, the hub couldn't be used to support topology with redundant links. In the case of LAN switching, the store and forward is performed like in routers too. Then LAN switches and routers performing this store and forward permit the adaptation of different bit rates and the examining the LAN switches and routers could examine the frame and in the case of routers, the packets, the level 3, the layer 3 packets. Both devices, LAN switches and routers, performing this function of store and forward, permit the separation of the collision domains. The difference then between LAN switches and routers remain in the forwarding functionality. The LAN switches perform only a filtering function based in the MAC address. But for instance, if MAC frame is designated to an unknown MAC address or is designated to a broadcast address, the LAN switch will flood the network. That is, will forward that frame over all other ports of the broadcast domain. Then that's why, for instance, the LAN switch don't separate the broadcast domain. And because this particular behavior of the flooding, the LAN switches, when we use redundant topology with redundant links, some loops could happen, and in that case, then we need to use a particular protocol called spanning tree protocol in order to avoid the loops blocking some ports. And in that way, we transform the topology of the network with redundant links in a tree topology that hasn't loops. In the case of the routers perform the forwarding of the datagrams. The datagrams will travel then within the MAC frames of the layer 2, and what is performed at the routers is a function called routing based in the destination IP address of the packets. In the case of the destination address that doesn't match any route in the routing table of the router, then the router will drop the packet or the datagram, and that's why in a topology with redundant links, the loops will not happen, and then we don't need to use a protocol like the spanning tree protocol that is used in the LAN switching technologies. Then the router will separate broadcast domains and typically avoid the loops and use efficiently the redundant topologies, because the router chooses the shortest path based in the destination address based routing.